So in this video, we're going to use this expected utility framework to think about the insurance market, which is really to say to think about the market for trading risk between one individual to another. So to think about this, let's take a more concrete example, a more real-life example. Let's imagine that you are a homeowner in Highland Park and you're worried about the risk of fires. So let's say that you've got a house worth $800,000. And you've got savings of $10,000. Right? The only problem is, in any given year, because of all the fireworks and wildfires and all this sort of stuff, you've got a 1% chance of your house burning down. Right? So, if we were just wanting to ask, what is the expected value of your assets? Right? How much do we expect you to own in an average year? We would just say, well, in a good year, right, when your stuff doesn't burn down, you're going to have $810,000. And then in a bad year, when your stuff does burn down, right, you're going to only have $10,000. Right? So our expectation of your assets is going to be 0.99 times 810,000 plus 0.01 times 10,000. Right? So what's this going to be? Well, it's going to be 10,000 plus 99%, or 99% of 800,000. 1% of 800,000 is 8,000, so this is going to be $802,000. Right? Cool. So in an average year, you're going to have $802,000. What about if we wanted to know, though, your expected utility under this circumstance, right? Taking into account the fact that you might value your first dollar more than you value your last dollar. So if we thought, let's stick with the same utility function we had before, right? If you have x, something like x to the 1/2, then we would say your expected utility would be 0.99 times 810,000 to the 1/2 plus 0.01 times 10,000 to the 1/2. Right? 810,000 is 81 times 10,000, so the square root of that is going to be 900. Right? 10,000 to the 1/2 is going to be 100 times 0.01 is going to be 1. Right? Great. Oh my goodness, I'm sorry, 0.99 times 900, right, plus 0.01 times 100, which is of course going to be, right, 1% of 900 is 9, so that's going to be 891 plus 1 equals 892. Right, so your expected utility is going to be 892. That's not all that interesting by itself, but we could say something like, since your utility is x to the 1/2, right, how much is this situation worth to you in terms of dollars that you have for sure? Right, so if we square this thing, we're going to get something like 795,000. So what we can say is, you'd be as happy with a net worth of 795,000 that wasn't in any risk, right, with 100% probability, as you are with $810,000 99% of the time and $10,000 1% of the time. So what this means, right, is that the average value of my assets is a lot higher than the value of this risky situation to me. Right? In other words, if I was willing to pay, say, $10,000, right, I could get I would have, in order to have the risk of having my house burned down taken away completely, I would be happy to do that, right? Because that would leave me with $800,000 for sure, which is better than having $795,000 for sure, which is how much I value my current situation. Right? So if someone was willing to offer, pay me $10,000 a year, and I'll take care of it if your house burns down, I would be very happy to take that offer. Now, of course, it turns out that there are people willing to make that offer, right, called insurance companies. The reason that the insurance company is willing to make that offer, right, is willing to say, pay me a certain amount every single year, regardless of whether your house burns down, and I'll give you money if your house does burn down, is because they're not just making this offer to me, they're making this offer to a million other people. Hopefully whether my house burns down in a certain year is unrelated to whether someone else's house burns down in that year. So because they've got massive, massive assets, right, they're spreading out their assets over a lot of very small insurance policies, they're essentially going to value their policies based on the expected number of dollars, right? They're not going to have a concave utility of money. So that means they'd be willing to make me any sort of an offer where on average, the premium they get from me is higher than the amount that they pay out to me, right? So their profit is going to be their premium, which I'll call A, minus the probability of a payout times the amount that they're insuring, right? Right, the value of their insurance. And so let's say, for example, that I had a premium of $10,000, right, which the customer is willing to pay. Then I would say $10,000 minus 0.01 times $800,000 is going to be 10,000 minus 8,000 is $2,000. Right, so the insurance company would be very, very happy to offer me that I'll pay them $10,000 a year, and they'll give me $800,000 if my house burns down. Right? And then I'll be fully insured. I'm going to know that I have $800,000 in assets for sure, right, with certainty, because I'm paying my $10,000 premium to have the insurance company buy me a new house if my house burns down. So one way to think about this is to draw this graph that I showed you before, right, of my assets against my utility for assets. Right, where I said that it's increasing at a decreasing rate. And let's say that on this graph, I'm going to put the value of 810. I'm going to put the value of $10,000. Right? And if I draw this line, what this is going to tell me, right, is the value of any sort of average between the two, right, between 810 and 10,000. Right, so if, for example, I had a 50% chance of having 810, a 50% chance of having 10,000, how happy would that make me? Well, it would be the utility of 10,000 times 0.5 plus the utility of 810,000 times 0.5, which is just going to be halfway along the line between these two utilities. Right? And as a result, if I think about the range of options, right, the range of alternatives that the insurance company is willing to give me, there's really a range of options from the value to me of this risk, right, my $795,000, all the way up to the expected number of dollars that I would get for $802,000. Right, in other words, in order to graph it, let's think about 50-50, right, because I don't want to have my graph be at the 99% versus 1%, right? So 802,000 is going to be the weighted average of these two numbers, right? The utility of 802,000 is going to be here, and then the utility of 795,000, right? My certainty equivalent is going to be here, right? Is how happy I am when I'm not being offered any sort of insurance at all. So what's the range of prices that I could be offered by the insurance company? Well, it's going to range from, right, prices that'll put me at 802,000 all the way to prices that'll put me at 795,000. Right? This value here going to give a certain name. I'm going to call this my certainty equivalent. Because that's essentially the amount of money that I would be equally happy to have for sure than to have the risky bet. This amount here, right, 802,000, I'm going to call my actuarially fair. Insurance payout, right, because this is essentially saying if the insurance company was making zero profit, right, so they were giving me insurance that my premiums are going to equal the expectation of the amount that I'm going to get paid back, right? Someone doing the calculation would decide that it's objectively fair. I would only have to pay $8,000, right? So that I had $802,000. Cool. So if I think about the value to me of having insurance, it's really going to be a function of two things. The first is going to be the risk that I'm taking, right? Whether I have a 1% chance or a 10% chance or a 50% chance or a 0.01% chance of having my house burned down. The other important component of this is going to be how bendy my utility function is, right? Again, the bigger the difference is between the shape of my indifference curve and the straight line, the bigger the negotiating range is going to be between me and the insurance company. In other words, the larger the benefit is, right, collective benefit is, for me to transfer my risk to the insurance company, it doesn't care about the level of risk. Cool. And what we're going to conclude here, right, in terms of how much insurance you should get, right, whether you should get an $800,000 payout or a $400,000 or a $200,000, is that because you care about risk and the insurance company doesn't, you should obviously get insurance for the entire value of the house, right? You should get paid out $800,000 when your house burns down because that maximizes the surplus between you and the insurance company.